Hi. In this lesson we're going to take a look at Newton's laws, and we're going to start with an introductory look at Newton's first law. This is also called the law of inertia. And we see the law written up here. It says an object at rest will stay at rest unless acted upon by an external force, and an object in motion will remain in motion unless acted upon by an external force. So let's talk through what this actually means, because I know sometimes when we read a law like this in a physics book, it can have that sciencey feel to it where it sounds a little intimidating. So let's talk about some everyday examples in which this law applies. So when we talk about an object at rest, that just means an object sitting still. The object is not moving in any direction. So it's not moving up, down, left, right. It's not accelerating, it's just remaining still. And when that object is acted upon by an external force is anything that applies a net force to the object. And that's one thing to keep in mind when you read external force. An object will remain at rest unless that external force has a positive net force on the object. Meaning, if I am standing still and not moving, then in order to be moved, a net force would have to be applied. If somebody pushes me from one side, I will then move in response to that force in the direction that that force is applied. Now the same thing for an object in motion. An object in motion will remain in motion unless acted upon by an external force. This is the part of Newton's first law that's oftentimes the most difficult to conceptualize, because what we see in everyday life oftentimes shows an object moving, but it comes to rest without a force seemingly applied to it. A good example of that might be something like driving a car. If you're driving a car at 30 miles an hour and you don't press the brakes, but you take your foot off the gas and you just let the car continue moving, you'll notice that the car will slow down, and if you were to let it go long enough, the car would eventually come to a stop. So we say to ourselves, well, that's odd. There doesn't seem to be a force being applied. Nothing is hitting the car, nothing is pushing the car to a stop. But keep in mind that some of the forces that we have in everyday life are friction. And in the case of driving a car and allowing it to coast to a stop, friction is being applied. It's a rolling friction on the wheels that helps slow that car down. There might even be a small amount of friction in the form of air resistance for a car traveling and air opposing the motion of that car. So there are external forces being applied, it's just harder for us to see. This part of Newton's first law is a little bit easier to conceptualize if we think of things in a vacuum. For example, things floating in space. In space, if you were to let go of an object, that object would continue in that direction until you grab that object again, or until some other force was applied to that object to stop it. So that's, for the second part of Newton's first law, probably an easier way to conceptualize this concept of objects in motion remaining in motion unless acted upon by an external force. Picture an astronaut that you've seen maybe in some sort of video where they let go of an object, or they throw an object upwards or downwards while they're in space, and that object continues floating in that direction until an external force is applied, or until that object runs into something else, somebody else grabs it, etc. So hopefully this clears up a little bit about Newton's first law. Please take a look at our videos on Newton's second and third laws, in which we'll actually do some practice problems to see how these laws can apply to physics questions. For more information, please visit our website at www.sandersontestprep.com. The link is in the description below. Thanks for watching.